Here we have a SAT math problem. Okay, let's go to the question. There is a triangle given over here. In the right triangle ABC above, AC equals to 10 and the value of sine A is 0.4. What is the length of DC? Okay, the length of the side AC is given, that is 10. And we have to find the length of this line segment DC over here. And the value of sine A is given, that is 0.4. Okay, now let me consider the complete right triangle, that is ABC over here. It is right angled at B. Then AC represents the hypotenuse. Okay, now we have the value of sine A, that is sine A equals to 0.4. So we know that whenever I want to get the value of the trigonometric function sine in right triangle, the formula is opposite side by hypotenuse. So let me write the stuff over here, equals to 0.4. So here in this right triangle ABC, which side is opposite side? So here we have sine A. Sine A means we have to consider the interior angle at the vertex A. So the side which is opposite to this interior angle is considered to be opposite side. So BC is the side which is opposite to this interior angle at the vertex A. So BC is the opposite side, and hypotenuse is the one which is opposite to the right angle. So AC is the side which is opposite to the right angle at vertex B. So AC is the hypotenuse. So the opposite side is BC and the hypotenuse is AC, which is equal to 0.4. We know the length of AC that is given in the question, that is 10. We can plug in 10 for this AC over here. Then I'm getting BC over 10 equals to 0.4. Now to get out the denominator 10 over here, we can multiply both sides of this equation by 10. When I multiply both sides by 10, I am getting 4. Okay, now I got the length of BC, that is 4, and already we have the length of AC, that is 10. Now, in this right triangle ABC, I am going to use Pythagorean theorem to get the length of the side AB. Okay, so according to the Pythagorean theorem, the sum of the squares of two legs of a right triangle is equal to the square of the hypotenuse. Okay, we know that AC is the hypotenuse because it is opposite to the right angle at the vertex B. So the remaining two legs are AB and BC. Okay, now let me square the two legs AB and BC and add them. That is AB square positive BC square, that is equal to the square of the hypotenuse, that is AC square. Okay, I do not know the length of AB, so let me keep this AB square as it is. I know the length of BC, that is 4. Let me plug in 4 for this BC, then we get 4 square. And for AC, I know the length is 10, then we get 10 square. Then I'm getting AB square positive, the 4 square is 16, then 10 square is 100. Let me subtract 16 from both sides. When I do so, this 16 negative 16 will cancel out. I am getting AB square equals to 100 negative 16. I am getting 84. Okay, now to get up the square over here, let me take square root on both sides. When I take square root on both sides, the square root and square will cancel out. Then I am getting the length of AB, that is equal to square root of 84. Let me mark it over here. Okay, now I got the length of the side AB of the right triangle ABC, that is square root of 84. Okay, now my aim is to get the length of this line segment DB. Once I get the length of this line segment DB, I can use Pythagorean theorem in this right triangle BDC to get the length of this line segment DC. So that's our aim, because that's what we have to find according to the question. Okay, now let me erase the stuff and continue the problem. Now, let me consider two right triangles over here. One is a triangle ABC, the right triangle ABC, and the other one is the right triangle ABD, because here we have a right angle. So here we have a straight angle. In this straight angle, the one part is a right angle over here, then the other part also must be right angle. So we have two right triangles. One is ABC and the other one is ABD over here. Okay, now let me write the vertices in order. Let me take two triangles. Okay, and A is a common vertex for both the right triangles. Let me write the common vertex at first. And now let me consider the vertex in the right triangle ABC at where we have right angle. Clearly that's vertex B. And in this triangle ABD, let me consider the vertex at where we have the right angle, that is D. And the third vertex of this right triangle is C. It's over here. And the third vertex for this right triangle is B. Let me write over here. Okay, here we find the vertex A in common in both the triangles. So that is, this is a common angle for both the triangles. So the angle measure of the vertex A over here, the angle measure of the vertex A over here is same because it's a common angle. And we have right angle at the vertex B in the right triangle ABC. So here at D, we have the right angle. So the angle measure at the vertex B over here, at D over here, are right angles, they are equal. So the two angles of this triangle are equal to two angles of this triangle. By angle similarity postulate, these two triangles are similar. Since these two triangles are similar, then the corresponding sides are proportional. Let me take the side AB in the first triangle. The corresponding side in the second triangle is, we have to consider the letters of the same question, that is AD. Let me write over here. Let me take the side BC in the first triangle, sorry. And the corresponding side in the second triangle is DB. Let me write it over here. Let me take the side AC in the first triangle. The corresponding side in the second triangle is AB. Okay, so since the two triangles are similar, the corresponding sides are proportional. Okay, now let me plug in the lengths. For AB, just now we got it, that is square root of 84, we can plug in. And for AD, I do not know the length. Let me keep this one as it is. For BC, I know the length, it's 4. And DB, I do not know the length, so we can write that one as it is. And for AC, we know the length, it's 10, that's given in the question itself. And for AB, we know the length, square root of 84. Okay, here all the three ratios are equal. So if I want, I can take any two of these three ratios. Okay, now let me take the second ratio and third ratio so that I'll be able to get the length of DB. Once I get the length of DB, as I said earlier, I can use Pythagorean theorem in this right triangle to get the length of the line segment DC. Okay, now we can ignore this one. Let's consider these two. So now what I'm going to do is, I'm going to take reciprocal on both sides. When you take reciprocal on both sides, I'm getting dB over 4 on the left side. When you take reciprocal for this one on the right side, I'm getting square root of 84 divided by 10. Okay, now let me multiply both sides of this equation by 4. Then 4 will cancel out. Then I'm getting dB equals to 2 goes into 4 2 times and 2 goes into 5 times. Then I'm getting 2 times square root of 84 divided by 5. Okay, I got the length of this line segment BD, that is 2 times square root of 84 divided by 5. Okay, now let's consider the right triangle we have over here, BDC. In this right triangle, we know the length of the hypotenuse, the side which is opposite to right angle over here, and also I know the length of one of the legs BD. So using Pythagorean theorem, you'll be able to get the length of the other leg DC. Okay, let me erase this stuff and continue the problem. Okay, now let me consider the right triangle we have over here. In this right triangle, BC is the hypotenuse because it's opposite to the right angle. BD and DC are the two legs. Okay, now let me square the two legs, DB and DC, and add them. Let me do it. So DB square positive DC square. So sum of the squares of two legs must be equal to the square of the hypotenuse, that is BC square. So now I just use the Pythagorean theorem and I have written this equation. Now let me plug in the length for DB. The length of DB is 2 times square root of 84 divided by 5 the whole square. And for DC, I do not know the length. That's what I have to find according to the question. Let me write DC the whole square as it is. For BC, we know the length, it's 4, then we have 4 square. Okay, now let me evaluate this one. When I take square for this 2, it will be 4. When I take square for this square root of 84, the square root will cancel. I'm just getting 84. And when I take square for the denominator of 5, it will become 25. Positive DC square equals to, the value of 4 square is 16. Okay, when I evaluate the value of this one, that is I multiplied 4 by 84 and the result is divided by 25, I am getting 13.44. Positive DC the whole square equals to 16. Now to solve for DC, let me get up this value. For that we have to subtract 13.44 from both sides. When I do so, this positive value, negative value will cancel out. I am getting DC square equals to, so when I simplify this one, I am getting 2.56. Okay, since our aim is to get the length of DC, we have to get up this square. For that we have to take a square root on both sides. Let me take it. And here on the right side also we have to take square root. So this square root and square will cancel out. Then I am getting DC on the left side. On the right side, when I take square root of 2.56, I am getting 1.6. Okay, now I got the length of this line segment DC, that is 1.6. We find 1.6 in answer choice A. The correct answer choice for this question is A.